Heat. Suzuki, like many automakers, utilizes the stamping process extensively in its vehicle manufacturing. Here's how stamping plays a crucial role in Suzuki's production. Body panels. Stamping is used to create various body panels, including doors, hoods, roofs, fenders, and trunklets. Chassis components. Structural components like chassis rails, cross members, and suspension brackets are also often produced using stamping process. Sheet metal preparation. High-strength steel sheets are fed into powerful stamping presses. Precision forming. Complex dies are used to shape the sheet metal into the desired components, such as door panels or hood sections. This may involve multiple stages of stamping, such as blanking, bending, and drawing. Quality control. Throughout the process, rigorous quality control checks are performed to ensure dimensional accuracy, surface finish, and the absence of defects. High production volume. Stamping enables the efficient production of large volumes of identical parts, which is crucial for mass production. Cost effectiveness. Stamping is generally a cost-effective method for producing complex metal components. Heat. Given Suzuki's focus on quality and efficiency, their Japanese factories likely utilize a combination of advanced welding techniques, including spot welding. Robots are extensively used for spot welding, a crucial process in automotive manufacturing. Robots can accurately and consistently place the welding electrodes and apply the necessary current, ensuring strong and reliable joints. Arc welding. Robotic arc welding systems, such as MIG or TIG welding, are employed for joining larger components or where higher strength is required. In some cases, laser welding may be used for critical joints, offering high precision and minimal heat distortion. Automated inspection systems. Advanced vision systems and sensors are used to inspect welds for defects such as porosity, cracks, or incomplete penetration. Experienced welders. Skilled welders play a vital role, especially for critical welds or those requiring specialized techniques. Suzuki's paint shops likely employ a sophisticated and efficient process to achieve high-quality finishes on their vehicles. Here's a general overview. Cleaning. The car bodies undergo a thorough cleaning process to remove any dirt, dust, oil, or other contaminants. This is crucial for proper paint adhesion. Surface preparation. The surfaces are prepared to ensure optimal paint adhesion. This may involve processes like phosphating, which creates a protective layer on the metal. Electrocoating. The car bodies are immersed in an electrically charged bath containing a water-based paint. This creates a uniform and corrosion-resistant undercoat. Primer application. Robotic systems apply primer coats evenly and efficiently. The primer provides a smooth and uniform base for the top coat. Top coat application. Advanced spraying systems. Robots equipped with advanced spraying technology apply the top coat, the color you see, with precision and minimal overspray. Color matching. Sophisticated color matching systems ensure consistent and accurate color reproduction across all vehicles. Clear coat application. A clear coat is applied over the top coat to protect the color, enhance gloss, and provide a durable finish. Drying and curing. The painted vehicles are then moved through a drying oven where the paint is cured at high temperatures. Automated inspection systems. Advanced vision systems and sensors are used to inspect the paint finish for any defects, such as orange peel, runs, or sags. Human inspection. Experienced technicians also visually inspect the paint finish to ensure the highest quality. Heat. Suzuki's assembly lines in Japan likely incorporate a blend of advanced manufacturing techniques and lean principles to ensure efficient and high-quality vehicle production. Just in time. Components are delivered to the assembly line precisely when needed, minimizing inventory and reducing waste. Continuous improvement. Constant evaluation and refinement of processes to identify and eliminate inefficiencies. Employee involvement. Empowering employees to identify and implement improvements in their work areas. Robotics. Robots play a significant role in various assembly tasks, such as component installation, installing engines, transmissions, and other major components. Welding. Performing precise welding operations. Material handling. Transporting components and subassemblies along the assembly line. Automated guided vehicles, AGVs. AGVs transport materials and components between workstations, optimizing material flow. In-process inspections. Quality checks are conducted at various stages throughout the assembly process to identify and address any issues early on. Visual inspections. Experienced technicians visually inspect the vehicles for any defects or inconsistencies. Testing. Completed vehicles undergo rigorous testing procedures, including road tests, to ensure they meet the highest quality standards.